Okay, box method. To start off with box method, we're going to start with some stuff that's going to be kind of feel irrelevant. So we're going to start with some really basic quadratics, and we're going to try solving them. Okay, so we call these level 1 questions, and there's going to be 5 levels. Today we're going to do levels 1 through 3, and then levels 4 and 5 will be for tomorrow. This is a level 1 box method question, where you have x squared, which means this is a quadratic, and it's equal to some number. If I told you to solve that quadratic, you could solve it pretty easy. How would you get x by itself? Square root both sides. So you square root, you get x equals 3. Simple, correct? So if you have something squared equal to a number, square root both sides and you're set. Okay, positive 3 is called the natural root. So it is what we've always learned. But there's also a second answer to this question. And I'm going to show you that second answer by just using logic. So 3 squared equals 9, correct? So we know that answer worked. What if I had negative 3 squared? What would that equal? It would also equal 9. So that means that 3 is the right answer, but negative 3 is also the right answer. So when you square root things from now on, starting today, you no longer get just a positive answer. You're getting a positive and a negative every time you square root something. So x equals positive or negative 3. So in the future, anytime you square root something, you're getting a positive and a negative solution. Because if you then put it back into the question, the negative would get canceled out by the square. All right, look at C. We have x squared equals a number. Something squared equals a number, square root both sides. That means x equals 11, but it's positive or negative 11. Both answers work. These are pretty easy. Square root both sides. We get x equals positive or negative. Square root of 50 is not a perfect square. So you would write it as positive or negative square root 50. It's a decimal. It's an irrational number. It goes forever. We don't want to write things like that. We always want exact values. So the exact value is positive or negative root 50. Why is that not the right answer? Unit 1. You have to simplify your radicals now. So when you square root things, you have to use your Unit 1 skills to simplify this radical. Root 50 changes into root 25, and root 2, which changes into 5 root 2. So your actual answer is x equals positive or negative 5 root 2. So those Unit 1 skills are going to continue on through this, basically the entire course. So when you square root something, if it's not a perfect square, check to see if you can simplify it. I saw a whole bunch of eyes be like, oh. It won't happen, like, if you're in this unit, you'll usually get nice numbers. So you're going to get like root 50 or root 32, like ones that easily simplify. You're not going to get like that Mars question where it was like the cube root of 1 billion. You're not going to see that. So don't be too freaked out by the fact you're going to have to be able to do that. All right, down here we have w squared equals 17. Get rid of a square, square root both sides. That means w equals positive or negative root 17. Don't forget the positive or negative. Root 17 is not a perfect root, and it can't be simplified. So that would be your final answer. We look at this one. We have something squared equals 27, but it's got a coefficient. So right now, if you try to do this, that wouldn't work, because you would have to square root the 3 and the y squared. So instead, what you do is you make sure you get whatever's squared by itself. So you divide both sides by 3. You have y squared equals 9. Now you can square root both sides. So get whatever's squared by itself first, and then solve it. Square root of 9 is just 3, so y equals positive negative. Well, those are easy, right? If you have something squared, to solve it, square root both sides. Alright, these questions are for you to practice. So I'll write the answers on the board. You try it on your own first. See if you get all the right answers. Check your work. I'm only going to give you like a couple minutes to do this one. Okay, so if we look through those, I've shown my work on the board for each one. I had x squared equals 100. Get x by itself. Square root both sides. Don't forget the positive or negative. Right? You have to now include that every time you square root something. So x equals plus or minus 10. If you look at B, you would have got positive or negative root 28, which can be simplified, right? It breaks into 4 and 7. The square root of 4 gives me a 2 out front. And it's positive or negative 2. So that 2 has to come out front. Look at the next one. You had to get whatever was squared by itself. So you move the x over. Then you could square root both sides. You got x equals positive or negative 3. You look at D, you had to get W by itself before you could square root both sides. Divide everything by 2, you get 25. Square root 25 is 5. Awesome. Hopefully those first 4 were pretty smooth sailing. The fifth one, not so smooth sailing. You had y squared equals negative 6. So you square rooted both sides. What happens when you square root a negative number? Yeah, it's not a real answer. It creates something called an imaginary number. I hope that you never have to go through the pain of understanding that. So, if you get that and you square a negative number, we just say there's no solution. We say it doesn't exist, no solution. So that's what I've written up on the board. That number doesn't exist, there's no solution. Awesome. Those were level 1. This is level 2. It's like a video game. Level 2 is a little bit harder, but it's pretty much the same thing as level 1 in the fact that you have something squared equals a number. The something squared is just a binomial now. It's the only thing that's changed, but it's still something squared equals a number. So if you want to solve something squared equals a number, what do you have to get rid of? The squared. How do you get rid of the squared? Square root both sides. So when you square root both sides, you now end up with x plus 2 equals positive or negative 5. This is the same concept, it's just now you have a binomial square instead of a monomial square. And this is fine and dandy, but we need to get x by itself. So now you have one more step, you need to subtract 2 from both sides. When you do that, this is how I write my answer. X equals negative 2 plus or minus 5. This means if you have whole numbers, which in this case we do, we have 2 answers here. The first answer is negative 2 plus 5. Negative 2 plus 5 is 3. The second answer you have is negative 2 minus 5. Negative 2 minus 5 is negative 7. So you have 2 solutions to this. And because they're whole numbers, we actually calculate what the solutions are. Any questions about that? Imagine that plus minus as you have 2 situations. If you plus it, second situation, if you subtract it. Alright, we tried B. We have something squared equals a number. To figure that out, we're going to square root both sides. Because that's going to be with x minus 7 equals plus or minus 4. We had something squared equals a number. We got rid of the squared. Now we're good. We can solve this thing by adding 7 to both sides. We write it out as x equals 7 plus or minus 14. There's 2 situations there. Situation 1 is if you do plus 14. Situation 2 is if you do minus 14. So situation 1, 7 plus 14. Yeah, it's 4. That's why I was trying to look. These looks like, oh god, I really screwed up. 4. 7 plus or minus 4. Better? Okay. 7 plus 4 is situation 1. That's 11. Situation 2 would be 7 minus 4. 7 minus 4 would be 4. So you have 2 answers. Yeah.
Do we stop at the x equals 7 plus minus 4, or the x equals 11?
11 comma 3 is where you'd stop. That's the answer. X equals 11 or 3. I'll show you a situation where we stopped earlier. It will happen.
Which is the next one?
No, the next one will work out as well. But the one after that one. So if we do C, we have something squared equals a number. Get rid of the square. That means you have x plus 5 equals, what's the square root of 0? 0. You have plus or minus 0. Does it really matter if it's plus 0 or minus 0?
That's what I didn't write.
Yeah, it doesn't matter. I wrote plus minus just to be like, you have to write it. It's the same thing. Positive 0, minus 0, makes no difference. It's still 0. So when we go to separate this thing out and we say subtract 5 from both sides, you have x equals negative 5 plus or minus 0. That's just x equals negative 5. And if you plus 0, makes no difference. If you subtract 0, makes no difference.
So we won't get our punch for that?
No. As long as you get down to x equals negative 5, you're good. If you skip that step even, you're good. D is where we're going to come into a new problem. So we have something squared equals a number. Get rid of the squared by squaring both sides. That'll leave me with w plus 2 equals plus or minus root 3. That can't be simplified. Root 3 is root 3. No way you're getting smaller. No way that's perfect. To get w by itself, you need to subtract 2 from both sides. Means w equals negative 2 plus or minus root 3. In this situation, you can't convert that into a nice whole number like we've been doing. So that right there would be your answer. You would say w equals minus 2 plus or minus root 3. That would be how you write that solution. Because it doesn't simplify. It's still an irrational number. We don't like irrational numbers. We like exact numbers. All right, for D or for E, we have something squared equals a number, but there's a coefficient in front of that something. So just like we did on the other questions, you need to get rid of that coefficient as your first step, so that you're back to the situation we wanted, which was something squared equals a number. Now you can square root both sides. X minus 2 equals positive or negative 3. That means x equals 2 plus or minus 3. X equals 5 or negative 1. Those are your two solutions. That's a little low on the board. So x equals 5 as situation 1, or it equals negative 1 as situation 2. Any questions on that? Cool. There's some practice here for you. We're not going to do the practice right now. We're going to try to do level 3 here, at least explain it, and then you can come back and do this. The answers that you're going to get are right on the board. You're going to get positive 8 plus 1, so you're going to be at 9 or negative 7. This one you're going to have x equals 7 or negative 1. This one's going to be x equals -1 plus or minus root 23. This one's going to be w equals 210 or -190. And this one's going to be x equals square root of 2 plus or minus square root of 12. If you want the answers, they're there for you. You can write them down. I wouldn't quote me on those answers. So if you end up doing it and you're like, I think he's wrong, if you're confident in your work, it's probably because I screwed up. That's what happens when you try doing things too quick. All right. Level 3. This is where stuff gets fun. And this is where we learn something called the box method. So we're going to start off with the same question. We're going to do 2 different ways. So right here we have a quadratic in general form. Our goal is to solve the quadratic. That's what the question is. To solve that quadratic, you factor it. When we factor it, we get 16, 10. Things that multiply with that is 82. Then we get x plus 8. X plus 2 equals 0. Means x equals -8 or -2. I did that fast. We've already covered factoring until I'm doing it fast. There's a second way that exists. It's called the box method. My suggestion is in this unit, always try your best to factor it first. So remember we went through those stages where I said, put it in general form, try factoring it, see if that works. That's always your first option. Did I do that right? Yeah. Okay. Always factor first. Trust me, it's what you're best at. You've been doing it for over a year for a reason. Because you were preparing for this moment, you didn't even know it. So factor is your first option. Why do you think? Because it's x plus 2, and so to solve that would be the opposite. The second way to do this is called the box method. The first thing you're going to do on the box method is draw a box. And that box has a little window in it, just like that. And what you're going to try to do is you're going to try to turn this quadratic into 2 binomials that are the same binomial. And that's what the box method is going to do for us. So what you're going to end up doing is asking yourself some questions. The first question is, what does this box represent? The box is an area diagram. Remember multiplying things together? And when we multiplied 2 binomials together, we got 4 terms. We know what those terms are going to be. I know that that first term is going to be x squared. I know that. Because that's the only way I get my x squared. What 2 things multiplied would give me x squared? X and x. Now, like I said, our goal was to create 2 binomials that were the exact same thing. So if your 2 binomials are going to be the exact same thing, that means your middle term, this 10x, has to split into 2 even parts. So what 2 numbers added together would be 10? 5 and 5. So I know I'm going to get 5x and 5x. And if this is an area diagram, then I need to ask myself, what number times x would give me 5x? 5. What number times x would give me 5x? 5. And what you just did was you created 2 binomials that were the exact same. One binomial is x plus 5, the other binomial is x plus 5. There's a problem with this method. And the problem is, what's the 4th box going to be equal to if that's an area diagram? Equal 25. And 25 does not equal 16. So what we do is we force this 16 to become 25. So what would I have to add to 16 to equal 25? Plus 9. So I'm going to add 16, or sorry, I'm going to add 9 to that 16 to make it equal 25. So I'm changing what this quadratic actually is. If you add something to one side of an equation, what do you got to do to the other? You got to add 9 to the other side of the equation as well. So you now have x squared plus 10x plus 25, correct? That's also equal to your two binomials times each other. We call that x plus 5 squared. So I just turned that quadratic into two binomials that are the same thing. And I wrote it as x plus 5 squared. And what's it equal? 9. It now equals 9. Because I've added 9 to both sides. What you're doing is you're creating a level 2 problem. You now have something squared equals a number. That's what the box method's doing for you. It's creating level 2 problems. If you square root both sides, you get x plus 5 equals positive or negative 9. If you subtract 5 from both sides, you get x equals negative 8 or negative 2, which is the exact same solution we got when we factored. How many people like factoring? Well, yeah, it's a lot more simple, isn't it? Yeah. Factoring is 100% the way to go, which is why I said your first step is to always see if you can factor. If factoring is so much easier, why do we bother learning the box method? Because sometimes things aren't going to be factorable. And if a quadratic's not factorable, you need a backup method to solve it. That backup method is the box method. So when you can't factor something, no longer will you say it's not factorable, you'll now have to do the box method to solve it. We're going to do box method a couple more times, just so you can get through it a couple times. I don't know if we're going to finish them all today. That's okay. We'll probably run through 2 more, and then we'll have to stop. And then tomorrow we'll do level 4 and 5, where it does get a little bit more difficult. So your first step to any question is to make it equal to 0, just to see if you can factor it. It's a good habit to get into. In this case, check to see if you can factor it. Things that multiply to be 2 and add to be 6 doesn't exist. So you can't factor that thing, so you have to resort to the box method. First step, draw a box. That box represents an area diagram. That area diagram represents this quadratic. We know that the first thing in the box always creates my first term. So I know that first thing in the box is going to be x squared. And now I ask myself, what two things that are the same multiply to be x squared? X and x. So I'm creating the outsides of my box by knowing what has to go on the inside. The next thing I do is I know that to get this middle term, I have to add up these 2 terms. And I want those things to be the same thing. So what 2 numbers that are the same add to be 6? 3 and 3. So I need to somehow get 3x and 3x. Now I can fill in the second parts of my binomials. What times x would give me 3x? What times x would give me x? 3. So you fill in all those parts of the area diagram using intuition and the information you have. The last part of the area diagram, you have to just calculate. And this one says 3 times 3 would be 9. Step 1 was make your box and fill out your box. We've done that. Does anyone have any questions about how we filled that out, where those numbers are coming from? The diagonals add to become the middle. The first box comes from the first term. The fourth one is just the result of your binomial. All right, step 2. You need to check to see how we can make the original quadratic equal our new quadratic. So our old C value is 2, our new C value is 9. How can I make 2 become 9? I need to add 7. It's the only way I can get from 2 to 9. So I add 7 to both sides. When I add 7 to both sides, I'm making a quadratic that is x squared plus 6x plus 9. But I know that that quadratic is actually equal to the sides of my boxes, which was x plus 3 squared. That's the jump that most people get stuck on. So I'm turning that quadratic into the sides of my boxes, because it's the same thing as just say x plus 3 squared. Equals, what's on the other side of my equal sign? 7. So I have x plus 3 squared equals 7. Now I have a level 2 problem. I have something squared equals a number. How do I solve that? I square root both sides. When I square root both sides, I have x plus 3 equals positive or negative root 7. I then have to move my 3 over, so it becomes x equals negative 3 plus or minus 7. That would be your final answer. That is a question that's not factorable, but you can still solve it. Tomorrow, we'll review maybe 1, maybe 2 feeling crazy, and then we're going to jump into level 4 and 5, and you'll have a quiz on Friday on all of them. If you want to practice it, try it. Not a bad